That's good. That's good. Hi, everyone. I'm Marcus. I work in dev relations and developer success for Edge and Node. And welcome to this introduction to the graph, quick start to subgraph development and querying. So I just want to be aware who here so far has deployed a subgraph. Go ahead and raise your hand. Okay, good. Awesome. Okay. Who here is aware of what subgraphs do or think they have a general awareness? Okay, cool. So we're starting kind of mishmash of experience. That's awesome. So this is perfect crowd for where we're going to get going. Let's go ahead and get started with the slideshow. And if there's any questions at any time, feel free just to pop your hand up. We can make this conversational. And we're going to get going right now. Let me put the timer on. Trying to keep this under time. So anyways, okay, let's get into it. First thing, let's start with an introduction to the graph. So when you go to thegraph.com, you're presented with this: access the world's blockchain data. So what does that mean? Accessing the world's blockchain data, it really does help to understand the very granular aspects of that, right at the root. And the root of blockchain data, smart contracts. We're looking at smart contracts to start this presentation. Let's break this down a little, and follow me through here. So what is a smart contract? Essentially, it's something like this. It's kind of like an Excel spreadsheet. And in a way, it just has data. That's all it is. It's just storing data. That's all it's doing. It doesn't have any idea about what's going on about the files around it. It's a singular data location. Now, in time, when you string them together, you actually can get a little bit of history on that data. You're actually able to understand data through time. And you can actually see what's been happening to that data over time, also known as data on the blockchain. You have smart contracts all over the blockchain. You're understanding data in a certain location, and you're understanding that data over time, okay? Now, it doesn't look like that. It's kind of Apple look right there. It looks like this. When you're going to an Explorer, you're seeing the data over time, and you're able to really understand that data through this Explorer. However, it's not easy to go through, all right? It's not really the easiest to understand. So instead, ideally, we have a system to figure that out. We're going to talk about the graph in a second, a little bit more, but I want to dive a little bit deeper into kind of the blockchain mechanics. Understanding the blockchain as a whole is write optimized. What do I mean by that? If you want to write something to the blockchain, you actually go through these nodes, the validators, and you're having that information written. And it's written in an unorganized way. Now, ideally, when it was originally hypothesized, we would be able to read that information directly from the blockchain. And you'd be able to see the front end right there. You can see the users up top here. And then there would be a write, and then there would be a read. And that would be that simple. However, it's not that simple. All right, we have a lot of disorganization on the blockchain because whoever's first on the blockchain gets their data written there. All right, just simply executed that way. So we have a read issue because it's so disorganized. We're seeing a single write going in, and then maybe a heck of a lot of reads for that single data point. And essentially what you have, let me give a metaphor for this, is who here has used Instagram today? Anyone use Instagram? Yes, there we go. All right, that's okay. Who here has shared a photo in the last week, either through a story, or a post, anything? There we go. Okay, cool. So that was a single write. All right. How many followers might read that? Maybe 100, 500, 1,000, 10,000. So you have a single write and maybe 10,000 reads for a single data point. And that's essentially what the blockchain read issue is. There's always going to be a lot of reads going on. How do we organize that information? Well, there's a Web 2.5 solution. And right now you're seeing here, we have a front end that is writing to the blockchain. And then we have a centralized indexing solution. And indexing is organizing data. That's all it's doing. It's organizing the data. However, it's centralized. And here we have a little data point coming from the blockchain, and it's going to our front end, but it also has Web 2.0 problems inside of its centralized nature. So if that goes away, all the advantages of the blockchain go away too. So it's really important that you understand that, okay, that is a solution, but it's not exactly a Web 3.0 solution. So the Web 3.0 blockchain read solution is as such, where instead of having read done by centralized indexing, we have a decentralized indexing capacity. And all of this data coming from this singular location is going to all of these different nodes and being populated to the front end. And if there's any issues on any of this, let's say there's potentially a node goes down somewhere around the world, we are still intact. That is okay. All right, and that is really the value proposition of the graph, is making sure there's a decentralized indexing and querying service being provided for security and making sure that we have really an incredible amount of just having layers of decentralization all the way through. Okay, so we love this. We can build truly decentralized apps this way. Having the front end even decentralized would be awesome too. And that is essentially the graph as a whole. It's a high-level overview. It's a decentralized indexing network protocol. Now, a little bit more about the graph network and how many indexers there are. There's 450 plus worldwide, permissionless. Anyone who wants to be an indexer can sign up. There's redundancy. We have lots of indexers all over the world. And it's fast, cheap, and reliable. It's a global open API. All right? So you're here to really get that high-level overview of the graph, which we've just done right there. But now we're getting into subgraphs, all right? So then what are subgraphs? Why do we need subgraphs? What's important about subgraphs? Well, really, let's just use an image here, all right? So let's say we are surrounded by blockchain data now, all right? We have all of this information, and we're just swimming in it. We don't know what's what. We don't know up from down, left from right. We don't really know what's going on. And we have all these nodes now deployed to the graph. Wouldn't it be nice if these were able to be organized really, really rapidly? So this is metaphorical, of course, where we are seeing live footage of subgraphs in action. But really, if we have a single data point, it needs to be organized in context with other data points. And that's what subgraphs provide. They provide the rules that actually this data could be organized and then accessed in an effective way. So let's go through and get a little bit more detailed on this process. The subgraph data pathway looks something like this. You have on-chain data, as well as potentially off-chain data through IPFS and file data sources. That will be piped into our subgraph manifest, kind of defining our shape of our subgraph. All right, that's going to be a file we're going to take a look at in just a second. From that definition of the subgraph manifest, we're looking at all the different types of data sources. We then transform that data with the mappings. Okay, so we have mappings.ts. This is the logic. It's kind of like, how do you want to organize this data? How do you want to put it into buckets? That's really what the mappings are doing. And then finally, once that's been organized well, we have the schema.graphql, so just known as the schema. That is how that data is queryable. You're actually able to send GraphQL queries to this schema. So I'll be going over this again, but really the one takeaway I want you guys to have from this is there's three main files you need to look at. You have subgraph.yaml, mappings.ts, and this name might change depending on the auto deploy, but just know it's in the src folder. And then you have schema.graphql. Those are the three key files that you need to be aware of and how they link. So once they link and you have that schema.graphql, you could send a query and then actually get that information from the decentralized graph network and from your subgraph, all right? And one little bit I want to add to this, each subgraph on the graph network that is published to the 450 plus indexers is a part of an incentivized marketplace. This is permissionless. This is Web3, which means you have to be able to incentivize people. And incentivizing people is done in the graph network using the GRT utility token. So indexers are incentivized. You're actually being able to participate in the graph network, and that's really important to understand that each of these subgraphs are permissionless. Anyone can build them. Anyone can actually start getting involved in their own way. So that's the overview of the graph and subgraphs. 1 to 2 billion queries per day, over 1,000 subgraphs on the graph network, and 450 plus indexers are working right now. So very cool stuff. If you would like, high-level overview was performed for subgraphs and the graph. Feel free to scan this QR code and tweet out that you are learning about Graph Protocol and really the high-level mechanics of it. And in just a second, we're going to dive in a little bit more. Any questions so far? Feeling good? Awesome. Cool. Wait till phones are down. Okay, cool. Okay, so let's get into it. Let's deploy and query a subgraph. Who here, if anyone wants to be live coding, you're free to hop in and pull up, open your laptop. If you do not want to, that is fine too. We'll just get into it. So you could also scan this and hop into the repo that was created for this, and I'll leave that open. Go. All the phones. Okay, awesome. Let's get into it. So let's deploy a subgraph. What we're going to do is deploy a subgraph that's going to look at the smart contract of CryptoPunks. All right, we're going to look at CryptoPunks. We're going to see how granular we can get and trace a single point of data, specifically an event, from the blockchain all the way and make it queryable. That's what we're going to do. So let's go ahead and start. First thing what we're going to do is let's go ahead and find the CryptoPunks actual address. All right, so what we're going to do, you can do this with me if you want, is go to Etherscan. Let me make this bigger. There we are. And so right here, we have CryptoPunks. Awesome. And we got the token contract right there, and also right at the top right there. I'll grab that. And we are looking for a few different data points here. We're looking for the ABI, the start block, smart contract name, events. That would just help us get aware of this. There's an amazing little app called miniscan.xyz that provides this to you super rapidly, just right in front of you. So you could dive into the Block Explorer. Feel free to do that. You don't have to. We'll just go to Miniscan, and I'll select Ethereum and paste in the contract address. And there it is. This is all relevant subgraph information to help you build more rapidly. We have the name of the smart contract. We have the start block from which the smart contract was initially deployed. We also can find the ABI, the actual code. We can actually go into the Explorer if we want. And we have the events that are actively being emitted from this smart contract. And right now, we're going to start looking at the transfer event, just highlighting that right now. Also, take a look at the start block, all this information. That's all great. Next, now that we have our research information through Miniscan, let's go to subgraph.com. And we're going to go up to Products, Subgraph Studio. And we're going to create a subgraph. We'll make this the House of Web3 Live CryptoPunks Demo. Okay. Index blockchain. We'll go on Ethereum. And we're going to create a subgraph. So right now, we have not deployed a subgraph. Of course, we're just spinning up our subgraph. This is the landing page, just getting you familiar with this. You're free to, of course, put this information, fill up this out as you'd like. But we're just going to skip all that right now just because I want to get building with you guys. And we're going to go into this location right here. So let's go through this, if you haven't done this before, and just copy paste this information as we go down into our terminal. So I'm going to pull up in my terminal. And and I'm going to make a directory. I'm going to call this Web3 demo, and then cd demo. There we go. And then we're going to get going. I've already installed this already, so feel free to do that on your own. But let's go ahead next, and we're going to graph init. All right, we have the studio, which is Subgraph Studio, which is where we're in. And I'm just going to run this live. Okay, so the protocol, we know that it's on Ethereum, so we just select that. The subgraph slug is already automatically populated from the initial flag right there. And then we automatically create a directory, just select everything as default. And then here we get to select the chain from which the smart contract is deployed to, and we have mainnet, so we'll select that. And then let's go ahead and say, all right, it's asking for our contract address. Let's go to Miniscan. We have our contract address and drop it right in. It's now fetching the ABI. It's also fetching the start block, all right? It does this automatically many times, but depending on the chain, I know some people here are going to be looking at different smart contracts, for example. If you're on a different chain, sometimes the ABI or start block is not able to be gathered. So that's just important that you can know, okay, if for whatever reason on the specific chain that you're at, you need to get the ABI, well, guess what? It's right here. You can click on that and say, all right, I've got my ABI. Control A, select it all, and then copy paste save as a JSON file. And then from there, it can be provided right to the CLI that way. So super easy through Miniscan. I really like using that. Let's go back. And then also same with the start block. It sometimes will ask you, hey, start block, and it can't populate it depending on the chain. Guess what? You've got the start block right there. Copy paste, and it automatically is doing it here. So very nice. Nice little developer experience situation. So it's asking for a contract name. Of course, you could just name it contract. It is standard to name it the proper name of the contract because you may eventually have multiple smart contracts you're indexing. So if you don't just want to name it contract, if you're eventually indexing 5, 10, 15 smart contracts, start with the actual name, and you'll thank yourself later. So all of that's been populated. Miniscan has been used. Index contract events as entities. This is where the magic begins. This is where we're actually deploying our subgraph. The true is what you want to do to scaffold out your subgraph. And it's doing it all in the background right now. We'll open this up in VS Code in a second. But now what it's doing is creating all of this, creating your subgraph for you, looking at all this information on the blockchain and making the development experience really, really easy to gather this information so you don't have to go parsing through block explorers because that can be tough. So let's do this. Taking its time. How's everyone doing? Any questions so far while this is spinning up? Yes. Ooh, okay, that's a great question. How can you trust the information you get from Etherscan? That's not the graph-centric question. How can we trust the information from Etherscan? I mean, I look at the information at Etherscan as truth. Does anyone want to chime in on that question? How do we trust the information on Etherscan? That is like, I mean, yeah, the best effort. It's the best effort we can do. Yeah. Yeah, yeah. There's truth to that. There's truth. Um, Ideally, we'll have a better solution in time. Yeah. So, do we want to add another contract? Yes, no. You could always select yes. We're going to select no just for the sake of this. So, next steps, you're free to go through this. I personally don't go through these next steps through here because Subgraph Studio makes this so easy. It's a lot more copy pasting. So we authenticate, which we're going to copy and paste right through there. And then we copy and CD into the directory that was automatically created. And then we graph codegen and graph build. We'll do that in a second because what that is doing is getting the subgraph ready to be deployed. What I want to do is actually start going through the files in just making sure that we understand the actual subgraph manifest, the actual mappings, as well as the actual deployment. So let's go through that right now. Oh, wait, just set this up earlier. That's okay. All right. There we go. I did this earlier. That's okay. Yeah, that's okay. Let's go. My path was set up earlier. Now it's not. Okay. There we go. Okay, so let's go through this and just understand that pathway. Remember that transfer event that we were looking at? All right, that really is going to be looked at initially by the subgraph by the, right here, the subgraph.yaml, which is also known as the manifest. Is that big enough for everyone? Can everyone see that? Cool. So this is how this subgraph is being defined. And it's manifest is a good name for it. It really looks at all of the different points of the subgraph that are important, defines them, and eventually when it is actually put into deployment and you're actually deploying the subgraph, it actually goes and is uploaded to IPFS. So you're actually able to have other nodes use this file. So it's really important that this information is accurate. And this was all populated. And you can see right now it's having an entity. It eventually will be populating an entity named transfer. Okay, so remember we're looking at that one. And what happens with this transfer event that's coming from the blockchain? Remember, we're going and saying, all right, well, what's coming from the blockchain here? There it is. We have a transfer event. Now, what should happen? Eventually, it will be handled. So it has a handle transfer event. Handler. Any questions about that so far? We have a smart contract emitting an event that is a transfer right there. And here's some of the data on it right there. And then it goes to the handle transfer handler, which we're going to go to in a second. Any questions so far? Cool. We're on it. Let's go ahead and see what the handle transfer event does. Let's go ahead and go into our mappings. And many times, this is, like I said, named mappings.ts. This automatically updates it at times to different names. Just make sure you know it's in the SRC folder. All of this was auto-populated. Let's go ahead and look for this handle transfer. There it is. So when the transfer event right there of type transfer event is emitted, what we're going to do is create an entity. All right. It's going to be a new transfer entity and it's going to have an ID. All right. It actually fills in this ID right here. All of this is being populated. And now we have a unique ID for this transfer event. It's going to then be put into an entity. We have an entity that has a from, an entity that has a to, an entity that has a value. And this information is going to be populated by the event params from, the event params to, and the event params.value. Anything params, by the way, is emitted by the event. All right, so this is all the event information being put onto the entity. And then here we also have a little bit more being populated. The block number, block time step, and transaction hash. All of this information is coming from the block itself. So it's just populating this entity and eventually being saved. This exact same pattern is done all the time. All right, you're simply getting an event from the blockchain, and then you're populating your entity from the event. You're going to see that over and over and over. Okay, any questions about that? Cool, cool, cool. All right, let's go ahead and go to the final part and trace this transfer event all the way into our actual schema.graphql. So here we are, the schema.graphql, and we have, there it is, our transfer entity. Okay, we've traced this from the blockchain. We saw it was existing. Now we have our ID, which was actually created by the subgraph automatically. So that's really cool. We also have the from, to, and value emitted through the event. And then we also have block information that's also being populated. This is an important thing to realize about subgraphs. You can start taking information from various locations and pipe it into your front GraphQL queries. All right, so now we have information from the block, we have information from transactions. Eventually, we can get tons of information from lots of different locations into our subgraph, into the GraphQL query. Okay, so let's go ahead and deploy this thing. What we're going to do now is graph code gen and graph build. We're going to compile it. And very nice. And we're going to deploy. Okay, we give it a version. And as it's doing that, we'll come back here and we'll see in real time. Boop, there it goes. And boop, there we go. All right, so now we have it synced. It's ready to rumble. And we can go to the playground and see how this is functioning. There we go. Live data right from the blockchain. And it's organized in terms of our GraphQL schema right through here that we just saw. Remember, we had the transfer event. If you want to start going and running some test queries, you can by just going onto this GraphQL Explorer. And there we go. We've got transfers, first 5. You can actually start filtering through here. And the from, ID, to, and the value. And very nice. Okay, so this is all live. This is really, really cool. I am really passionate about this because you're able to actually get raw information organized from the blockchain. I think it's super duper cool. Let's go back into the presentation. Any questions about this so far? Does that kind of make sense in tracing this all the way through? Cool, not getting any questions. Awesome, 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 awesome. So let's go ahead, and we've done this already. We followed the transfer event. We had the on-chain data transfer event we're reviewing here. It goes into, is defined the subgraph manifest. Let's make it bigger. It is then goes in, the logic is done in the mappings, and then we actually are able to present that data in the schema.graphql and then query it. So let's go into some patterns that you'll be seeing. I'm just going to go over these quickly. You'll see these a lot in subgraphs, and then in a more advanced subgraph I'll show you in a second, you'll see these for sure. A rough NFT schema entity overview. Generally speaking, when interacting with an NFT, you're going to want to know information and aggregate that information in a contract entity, an account entity. You're going to want to understand information about the NFT. You're going to want to understand its traits, metadata, the event interface. You're going to want to understand all this. You might not get all this right now. Don't worry. I'll go into this in another subgraph in a second. There's other things you want to take a look at in terms of patterns. We have immutable events. Immutable events are events essentially, if you're having events emitted from the blockchain and you're not changing any of the mapping, you're not changing any logic, you don't really need to do anything to it. It should be immutable. The event should be named immutable, and that really speeds up indexing performance. Really helpful for when you're trying to keep logs of things, okay? Also, you could link entities in your schema. You can use this right here, this kind of shape to have a reverse lookup. That's the derived lookup right there, derived from lookup. And that's going to be helpful for connecting different entities together and having them be able to have these virtual relationships that your front end GraphQL can query. It's very powerful. And then also aggregation entities. Anytime you have something that you really want to know a lot about, that's an aggregation entity, and you can pipe in information for a lot of it. So contract is a good example of one where you can bring in a lot of different information from a lot of different sources and say, this is a lot of information about the contract. Also, a big thing about assembly script is that it doesn't like null things. You need to have checks all the time. So what you need to do for a lot of these different types and a lot of these different creating of subgraphs moments, you need to have get or create moments where if a certain entity is not in existence, you need to check to see if it's in existence, and then if it's not, you need to actually create one. All right, so this is really important to have in your mappings. Okay, a few other tips and tricks. Emit all information that you want to store in the database as events. If you have the availability of the smart contract, make sure you have events being emitted that have valuable data. Feel free to go through this. This is more just kind of like little tips and tricks for the future. And then finally, querying the decentralized network. Let's get into it. So far, right now, we have a subgraph that I was able to spin up with you guys. Let's look at a more advanced subgraph briefly, and I would actually, let's do this on your own time, I think that'd be best, where you can compare your subgraph, that boilerplate subgraph that was spun up, to a really advanced subgraph, the CryptoPunks subgraph done here, and I put the links in the repo. If I were you guys, what I would do is I would look at this basic subgraph that you've spun up, and then I would compare it to this more built-up subgraph, and compare and contrast and say, okay, well, this is what my subgraph can do. What can this more advanced subgraph do that's looking essentially at the same data points, and how much more creative can it be? That's a big learning thing that I think would be very helpful to really get into the groove of seeing what can be done. And then here are some questions that you can actually start to ask yourself when you are in the playground. You can go ahead and see what your boilerplate subgraph could do and answer some of these questions. Some of these questions right here could be answered by a boilerplate subgraph that you've deployed, and some require the more advanced subgraph deployed and actually published on the decentralized network. So if I were you guys, I would hop in, see which questions you could answer with the subgraph that you've spun up, as well as the one that is more advanced. Finally, when your front end is ready to begin regularly querying these subgraphs on the decentralized network, go ahead and set up your API key. You can get 1,000 free queries and go ahead and use that through Subgraph Studio. And then from there, you could actually go ahead and query to your heart's content through your front end. So to review, we've gone through and installed dependencies. We found the contract. We've initialized the subgraph with events. We've created a subgraph in Studio, and we deployed a subgraph. Now, up to you guys, is enhancing your subgraph with logical entities and improved mappings. I would really recommend you guys do that. And also update your subgraph, further enhance, and eventually, when you're ready, publish your subgraph to the decentralized network. And that is the CryptoPunks subgraph that I referenced earlier that is active on the network. Finally, feel free to join the Graph ecosystem. Feel free to scan this to learn more about the graph as a whole. And that is the end of this presentation. So I want to thank you all for coming through here today. And if you have any questions, feel free to ask. Thank you for your time. Any questions? I'll be around. I'm not going anywhere. So if you don't want to raise your hand, that's okay. Question? Yes. Great. So it's permissionless. What I would do is if you want to go onto Discord, there is an indexers channel, and you could just hop in, and there's indexers hanging out there all the time. And you can say, hey, I'm interested, and you just get people who are just helpful. They're very helpful. That would be what I would do. Yeah, of course. Awesome. 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 Well, thank you so much for your time, everybody. I'll see you guys out there in Web3 land soon. All right. Take care. All right.